Hi, in this video we'll go over modeling with UML. More specifically, we'll look at activity diagrams. UML stands for Unified Modeling Language, and in the previous videos we looked at use case, class diagrams and state charts. Today we'll look at activity diagram. An activity diagram is similar to state charts, but it's a special case of state charts. In the states in this case are not state of an object like in the case of state diagrams, but it's activities or functions. You can think of activity diagrams as the purpose is more so to depict the workflow in the system. So say for example, if it's an incident, a system to handle different kinds of emergency incidents, then an activity diagram would look like the one shown here in the diagram, where the first function or activity is to handle the incident, followed by documenting the incident, followed by archiving the incident. Now, one key difference that you would see here from a state chart is that the edges are not labeled. So there is no specific trigger or event causing this the first activity to move into the second activity. The trigger by default is basically completion of the activity. When handle incident is completed or done, when the functionalities, all of the steps for that function have been performed, then we move on into the next activity and then into the next activity and so on. So the key differences between activity and state diagrams are that in activity diagrams, the nodes are basically activities or functions. They're not states of an object. And then there is no explicit trigger or stimuli like in the case of state charts. Here the stimuli is the completion of an activity. So the purpose of activity diagrams are to depict a workflow in the system and to show how the event flow happens. So that's really the idea here. So here's the same example of the emergency incident handling system. So say there is an incident that comes into the system. The first step or the first activity is to open an incident record, and then some kind of decision making may be needed. So depending on the priority of the incident, if it's a low priority, is it a low priority, is it a fire and high priority, or is it not fire and high priority? So those are the three possible, based on a certain condition, there's three different paths that can be taken. So if it's not fire but high priority, then the next activity would be to notify the police chief, and then followed by allocating resources to handle that incident. Now, if it is fire and high priority, then we want to notify the fire chief first. We do that first, followed by allocating resources. If it is a low priority incident, then we don't need to notify anyone. We just directly allocate resources for it. So as you can see, very similar to state charts. It's just that here our edges are just whenever the activity is completed. So we are thinking of our nodes in terms of activities, and then if there's some, based on certain decisions, if the next activity in the workflow has to be different, then that can be shown using this decision symbol, and then so in that case, for the condition is specified on top of the edge as a label. So is it low priority, fire and high priority? Those are our conditions that hold, and they're specified as a label on the edge. Now, a few more things that we can do with activity diagrams are we can model concurrency. So basically, if this synchronization needed for multiple activities, and that can be shown by splitting the flow of control. So the flow of control can be split into multiple threads, so that there could be some activities that happen in parallel at the same time, and then and maybe the results of those activities need to be synchronized before the next activity occurs. So that's possible through the splitting and through the split and fork. So what you see over here is basically we want to open an incident, and after the incident record is opened, here's where the splitting action occurs. So we can split the flow of control into 3 threads. So what's being said here is that resources can be allocated, resources can be coordinated, and documentation of the incident. All of these 3 activities can happen at the same time in parallel. So that's the reason we have split it into these 3. The flow of control has been split into 3 threads. But then our final activity of archiving cannot occur until all 3 of these previous incident activities have been completed. So that's where we use the synchronization, and we're going to wait for all 3 threads to complete. So the synchronization symbol over here is waiting for that, and only when all the threads have completed their activity, that's when the next activity of archiving is invoked. So again, basically another way to represent workflow where concurrency is to be modeled, and it's done through this split and synchronization notation. Another thing that can be done with activity diagrams is that activities could be grouped into what are called swim lanes. Really, the purpose over here is to basically denote objects or subsystems that implement the activities, to basically show who's responsible, which object is responsible for a particular activity. So we can group them according to the object or into subsystems. So in this case, say there are 2 objects, dispatcher and field officer. They're going to be involved in some of these activities, maybe not all. So the dispatcher is involved in opening the incident, allocating resources, coordinate resources, and archiving incident. That's the reason there is a separate swim lane for all of the activities related to the dispatcher. And the field officer is involved in just one activity, document incident. So that's placed in a separate swim lane. So this is basically a way of arranging the diagram and arranging the activities into these groups, into subgroups, for more clarity and on who is responsible for what, or which subsystem does a particular activity belong to. Now, state diagrams versus activity diagrams. It's important to understand the difference between these two because they look very similar in terms of the notation. Now, the focus with state charts is on a single abstraction. So, on a single object or a single system and the different states that this object can be in. And another key difference is that the states change on specific stimuli, on specific triggers, like an incident has been handled, an incident has been documented. So there's specific triggers. Whereas in an activity diagram, there's no specific triggers. The trigger by default is completion of a task, and then the purpose or the focus of the activity diagram is on the data flow in the system, the data flow and the workflow of an entire system. So that's what the activity diagram focuses on. So it's very important to understand this key differences between state charts and activity diagrams, and knowing when to use which one. Basically, when we are trying to understand a given specification and come up with the models, the idea is to, if there is a particularly complex object, then state chart helps in better understanding that particular object. And an activity diagram helps in understanding the workflow within a subsystem or a system. Okay. Now here's another example, and this is for a document management system. So that entire process is represented using an activity diagram, and we've used multiple swim lanes here. So these swim lanes are based on these objects that are responsible for some of the activities. So in the document management process, typically there is an author of the document, there is a reviewer of the document, an approver, and an owner of the document. So there are some activities that each of them are involved in. Just like so basically we have our start state and a final state. So that's the final state. So in the start state, the first activity is basically creation of the document. It's the author who's involved in it. That's the reason it's inside the author's swim lane. Once the document is created, now in this notation you will see that there is a new, we use a rectangle symbol to indicate data flow. So any data that's flowing from one activity to another is indicated using that rectangle symbol. In this case, that data is the draft document. So the author creates a draft document and sends it to reviewing draft activity. That's the second activity that's done by the reviewer. Then a reviewed document is passed on to approve, the next activity that's done by the approver. And then there's the decision making of whether this document is approved or not. If it's approved, then it becomes an effective document and moves further in the workflow. If it's not approved, then it's taken back into the author swim lane and the author updates it. So there's the update activity. And then once the author updates it, again sends the draft document back to review, and from review to approve, and so on. A document that's approved, it gets into review effective phase, and from there, depending on if changes are needed or if it's obsolete, if changes are needed, then a change request is created and it's sent to the author again. If there's no changes needed, then it goes into an archive activity, which is in the owner's swim lane, and that's the final state. From archive, we basically get into the final states. The process is complete. If there's a change request, it goes back to the author and it gets back into the cycle again. So here you see, again, we've used a number of different features of the activity diagram. It shows the decision making, it shows swim lanes, and it also shows this how data flows from one activity to another, and if there is a specific data and if the data needs to be shown, then that can be depicted of being passed from one activity to another. That was all of the basic activity diagram related notation. Let's look at this exercise wherein we have to draw an activity diagram for fulfillment of an order. Now this order is first received. So the process basically is that the order is first received and then it is processed. An invoice is produced. So by processing, what I mean is it available? Is sufficient amount available? So that kind of processing is done, and if it is, then the invoice is produced, and then it is delivered either using overnight or regular shipping based on what was chosen. And then the payment is received before the order is closed. So this is more like a business-to-business transaction, not a typical online shopping kind of transaction. That's the reason there's an invoice produced, and then irrespective of whether payment is received or not, the shipping is taken care of, and then the payment is independently received, and only when the payment is received, that's when the order is finally closed and the process is complete. So we need to create an activity diagram for this. So let's see. As always, we start with the start state. Our first activity is receiving the order. Once the order is received, here we have a splitting action, because certain activities can happen concurrently. So the order can be filled and the invoice can be produced. Both of these can be done parallelly. The invoice can be produced and then it's sent to the customer, and then the activity after that is to receive the payment. Now on this side where the order is filled, and once the order is filled, the delivery process begins. So as you can see, the delivery is one big activity, and under that there could be sub activities. So the sub activities are, for the delivery process, there is a decision making to be done. Is it a rush order or a regular order? If it's rush order, we go with overnight delivery, else with regular delivery. And then the sub activity is completed. So there's a start and end state for the sub activity diagram. Now from there, when delivery is completed and when the payment is received, so again we are waiting over there for synchronization. So there's the synchronization symbol, because the flow of control was split into two threads. So we want to make sure both threads are complete before we get to close order. So when both threads are complete, the last activity is close order, and that's the final activity. So basically that's again here we haven't used swim lanes because there isn't much significance of who's responsible for what, but if that clarity is there, if that's needed, then swim lanes can be used for that purpose. But we've used the splitting and synchronization and decision making, and then we've shown how you can have a sub-activity diagram for a particular activity. You can have sub-activities depicted inside of it. So that's activity diagrams, because the key thing here is make sure to understand the difference between a state chart and an activity diagram. They seem very similar, but their purpose is very different. So UML basically provides this wide variety of notation to come up with these different kinds of models and handle the complexity of software development through modeling. It is also a programming language. Now, we want to be careful. It does provide a lot of features, sometimes too many features that can make the models very hard or unreadable, and it cannot be interpreted correctly. So that's the reason we want to keep our models simple, but at the same time manage that complexity and understand what we are trying to create through those models. So we focused on the key notations that are important, the 20% of the notation using which most modeling can be done. So we looked at use case diagrams, which help create functional models, class diagrams that help create object models, and then we looked at state chart and activity diagrams that help create dynamic models, which were the three kinds of system models to deal with the abstraction aspect of software development. Now UML, the tools, there is a lot of tool support, and tools help in converting those models into template code as well, skeleton code as well. So that feature can be used, and it's basically a model driven development. So that's the end of this lecture. In the future lectures, we'll look at software processes and software development life cycles, and how software development can be done in a systematic way. Thank you.